three here. The very first diagram what we picked up, no? Okay, let this be a path. There's a one path. There's another path. Let me draw bigger lines. Okay, no, we have, there's a pressure, volume, that one. So there's a path A, B, and C. So there's a state 1, 2. Can you say about the internal energy? Change in energy, delta UA equal to delta UB equal to delta U. So will agree? Path independent change in energy. What about the work done? Anybody wants to comment work done?
Different, sir.
Which will be greater?
C, sir.
B, huh?
C, sir.
C, area under the curve. Area under the curve, C is more than area under the curve A or B.
A, sir.
So this one, so I'll give small diagrams, at least. See, you have to put pressure on your, you can't just blank brain. You should fight, okay, well, how that area will be. Okay, immediately take pen, paper, try to draw diagram. The area will come this much. I'm shading this, so definitely which particular area will be more is what, at least if you tell it. Okay, sir, how areas are different means I can't help you. Huh? Basic geometry. So these are the path like this. So like this, what happened? We are going to compare. So this is the path C, path A, path B. So WC, WA, which area is more here? WC greater than WA, no? Agree this? This will be. Okay, now what about the heat exchange? Can we say more? Okay, here is what I'm going to relate the heat exchange, change in energy, and the work done. That is what, nothing but the first law of thermodynamics I'm going to introduce. So how all these three energies are related. Okay, let's see that. What is the energy? Kinetic energy of molecules. No? What is Q? The heat what we are going to supply. It's some sort of heat. Heat is a form of energy. We all know it. And this is what energy, kinetic energy of molecule. What is work done? It's the effect of gas. No, the gas can do work. The gas, what happens if the gas does work? Tell me what changes will notice. Tell me if a gas does work, what will happen to piston? Piston will accelerate. Piston will have velocity. So therefore, when you say gas does work, immediately what will happen? There will be some changes in the what happened in the piston, or the piston will acquire kinetic energy. So like this is what we should remain. So since it can, many changes, external changes will come. A good example, why car will move? Because the gas does work. Because of that, car is moving. Why thermodynamics is given so much of importance is like the gas only. Why refrigerator is so cool? Because the gas is doing work. Why air conditioner cooling effect in the room is there? Because of gas does work. So don't think that only piston gas does work, piston will move. It all depends upon the application. For the locomotive engines, the piston movement is what which will help us to move the vehicle. Aeroplanes, rockets, everywhere, no? The work done by the gas is what taken into picture. Refrigerator, air conditioner. Just imagine what all we have, the modern transportation just depends on this thermodynamics. Work done by the gas. Hmm? So now I say that work done by the gas. As this will be used for some application. Let's not bother this one. Or if you just bring a piston, yes, the piston here in this case, what happen will have more increase in kinetic energy than this. It should be understood here. So so now what is work done by the gas? There'll be some change in kinetic energy of piston. At this level, you can imagine at least that much here. Okay, now let me relate first law of thermodynamics. So what is telling is relating the heat with change in intensity, then work done by the gas. Or in the differential form, you can write very specifically. I'm writing because it is understood work done means work done by gas only. So to make things clear, I'm writing gas, but other is not needed. This will be in the differential form. So now what is this? Nothing but shall I say law of conservation of energy principle, not mechanical energy. So what is this? Heat, kinetic energy of molecules. What about this? Some agent, somebody will receive that energy from the gas, and that will be available as kinetic energy of piston or elastic potential energy of spring or work done to overcome friction or any other thing. Like that, all these three quantities are related. Okay, now keeping this in mind, delta U is same for all the three paths. Delta U is same for all three paths. WC greater than WA, WB. So what you can say QC, QC greater than QA greater than QB. Agreed? So how do you can say? Because from first law, delta U is same for all the gases. WC greater than WA greater than WB. So therefore QC greater than QA greater than QB. So which are path dependent? Heat exchange and the work done are path dependent. Which is path independent? Work done, sorry, change in intensity. Like this, I'm just introduced the first law. There's nothing but what happened. What is first law of thermodynamics? Another form of law of conservation of energy. Okay, like this is what we have just had a very nice conclusion about the different parameters here. Okay, let's get into the work done because still many other things is what I should define. Let me go back to the work done. Okay, we do have a cyclic process.